So the process is kind of the same. The first thing we want to do is identify the constant VSWR circle, which corresponds to our input impedance, and we want to figure out what constant conductance circle our load impedance sits on. We have to choose if we're going to go to point A, if we're going to go to point B. So let's go to point A. So the first thing we do, very straightforward, we figure out what constant susceptance line point A sits on, and we figure out what constant susceptance line the load impedance sits on. We find the difference between these two values. We see that the change in susceptance is positive, so that suggests that we want to start as an open circuit because we want to go into the lower half of the Smith chart. So we read the scale here of the constant susceptance lines, and we figure out where the constant susceptance equal to 0.45 is. We make our rotation from the open circuit to that constant susceptance line, and then we read the length of the transmission line from using the outside scale of the Smith chart. Okay, so here we see it's 0.067, so where'd that come from? At this point here, we have 0.25, and at this point here, we have this is 0.31, this would be 312, 314, 316, so 317, and then the difference between those two values should be, close to 0.067. So now that tells us the length of the stub required to transform the load impedance from this point on the Smith chart over to point A. And now, like I said at the beginning, in order to figure out how long the series transmission line needs to be, we extend a line from the center through point A and from the center through our desired impedance, and then we read the outside scale of the Smith chart. So here it equals about 0.4025, and then over here it equals about 0.168. We recall what I said about how this kind of has to be broken up into two steps. We know that here is 0.5, and right here is 0.4. So this distance between here and here is, approximately 0.1. And then we have this part of the scale here, which goes from 0 to 0.168 here. So what you see here is, the 0.1, which is the measurement from point A to the beginning of the scale, and then this 0.168 is this other measurement from the beginning of the scale to our input impedance location here. Okay, so when you make this subtraction and you add on the 0.168, you get the same result that we got taking the other longer approach.